Hello guys, hello everybody, hello all parts of the world, welcome to my live streaming. Okay, so now we will be able to have problem solving on how to use the steam table. As what I discussed yesterday, we have two types of steam table. We have the saturated steam table, okay, and the superheated steam table. So I will show you here. This is our saturated steam table. So we have, this is really the temperature based steam table, and the temperature is listed here. Okay, and besides is the pressure, corresponding saturated pressure also, and the rest will be the other properties given which corresponds to the specific saturation temperature here. Okay, like that. Okay, this is the saturated steam table, temperature based. Okay, now we have the other properties. So volume, this is specific volume. The unit is cubic meter per kilogram. We have also the energy, kilojoules per kilogram. We have the enthalpy, kilojoules per kilogram. And we have also the entropy, kilojoules per kilogram Kelvin. Now we have here the units each presented here. Okay. Okay. So actually this steam table could be found in your chemistry books or physics book. Then if you are taking chemical engineering course, it is also found in your Paris Chemical Engineer's Handbook. Okay, like that. All you have to do is to scan for it to find this properties listed here. Now, I will be able to mention the unit. The temperature is in terms of degrees Celsius. You don't have to convert that to Kelvin, to Rankine, okay, and to degrees Fahrenheit. So as is, if what is the given temperature, then you have to apply that. This is degrees Celsius. You don't have to change. Okay, then in the problem, usually another unit of temperature, then you convert that to Celsius because the Celsius here is given. Okay, something like that. Our pressure at saturation is megapascal. Since this is megapascal class, so if the problem will state another unit of pressure, for example mmHg, then you'll be able to convert that to megapascal here so that you can get other properties here. Okay, so what's the relation for Pascal and mmHg? So you can easily get that one. So 760 mmHg is equal to 101,325 Pascal. Okay, like that. 101,325 Pascal is equals to 1 atmosphere. Okay, 1 atmosphere is equals to 1.013 bar. Okay, like that. So there's a relationship among the units of pressures. Then you have to inculcate that in your mind, the different units of pressures. Then bingo, you can get that here in the saturation pressure, which is the unit here is megapascal. All you have to do is to use the 101,325 Pascal, or you can use the 101.325 kilopascal, like that. Okay, so that you can achieve 2 megapascal. Then mega is 1 times 10 to the 6. Okay, then you can convert that directly using the conversion factors. Then easily you can get that one. Okay, very basic math for that. I don't have to teach you because it's very basic math. So in high school, there's already conversion factors there. It's being taught in high school. Then it is also very understandable that you and me and everybody knows how to convert easy units, especially in pressure. Okay, now we go to the volume here. Okay, volume here. So volume is in terms of cubic meter per kilogram. So as you can see, class, this is not a very common volume because the denominator is kilogram. Okay, so this means this is a specific volume. So when we speak about specific, there's a denominator for that. not a direct unit. As we learn in our physics and our chemistry, we have a volume unit, right? Could it be cubic meter, milliliter, something like that, gallons, or whatever, but there's no denominator in it. But in here, in the specific volume, there's a denominator of kilogram. So cubic meter per kilogram. And our numerator is always the volume, okay? And our denominator should always be the mass. So we can say really that specific volume is talking also the mass because it's being expressed in the denominator. Okay, so you can easily now identify in different examination that if a problem will give a specific volume, automatically there will be a kilogram in the denominator, or could it be a gram. Then if you really want to get the regular volume, then specific volume times the volume regular. Okay, for example, I have a coffee here, something like that, and then I need to get my volume. I have a specific volume, so I have to multiply this by the mass with this cup and coffee. So when I multiply that one, okay, specific volume times the mass of this entire cup and coffee, then I can get the regular volume for this cup of coffee, something like that. So that is an actual example how to determine actual volume by having the specific volume in our problem. Okay, let's go to energy, kilojoules per kilogram. Again, this type of energy has a kilogram in the denominator, meaning to say this is specific energy. Okay, so specific energy, or technically or theoretically, this is really internal energy. We are referring this all the time in the first law and second law of thermodynamics, especially in first law of thermodynamics that talks about more of energy, the law of conservation of energy. Okay, let's recall. Law of conservation of energy, the first law of thermodynamics states that, okay, energy can neither be created nor can be destroyed, but it can only be transformed for various types of energies. Something like that. Okay, what are those energies? So we have a lot of energies in our planet Earth that surrounds us. We have the chemical energy, mechanical energy, electrical energy, acoustic energy, sound energy, radiation energy, thermal energy, pneumatic energy, hydraulic energy, geothermal energy, kinetic energy, potential energy, radiation energy. Okay, so many energies around us, and we cannot live and cannot survive in this contemporary world without those energies around us. Okay, specifically the heat energy or the thermal energy. Then if we don't have that in our body right now, then we cannot proceed to do work. Okay, if we don't have heat energy, we cannot proceed our job. Okay, we cannot write, we cannot sing, we cannot dance, we cannot cook. Okay, we cannot talk, we cannot go to our appointments if we don't have heat energy, because heat energy is a requirement of metabolism. Okay, so heat energy is very, very important. Okay, the main source of heat energy is really our fats, the conversion of fats, right, into fatty acids, so that it will be used as a fuel. Okay, it will go to our bloodstream. Again, it will be released in our liver, those fatty acids coming from the fats. Okay, and then it will go to the bloodstream and it will be used as a fuel. Okay, and drive our metabolism and other support muscles function. That's why we can stand, we can do, because we have heat energy. And heat energy also is very important in relationship with internal energy, because these two energies are really have a close relationship if we try to account the first law of thermodynamics and the second law of thermodynamics. Okay, especially in thermochemistry specifically, guys. Okay, now go back to enthalpy. Okay, enthalpy, kilojoules per kilogram. Again, there's a denominator of kilogram. This meaning to say this is specific enthalpy. Okay, as we can remember and we can recall based on my previous discussion, I said that enthalpy is the total heat content in the system. Something like that. If I am sitting here, I am the system, and this is the room, this is my office, this is the surrounding, okay? Then I can be able to release my enthalpy, my heat content in my body, and the heat energy will be transferred around the surrounding, something like that. Or in reverse, there's also heat energy coming from the surrounding, and it will be transferred to me. So the process is gonna be exothermic reaction or endothermic reaction. When I release heat to the surrounding, that is exothermic reaction. When I receive heat energy from the surrounding, and that is endothermic reaction, something like that, okay? And we need also to account the spontaneity of the chemical reactions. How spontaneous, how unspontaneous is that? So that we can determine how slow and fast our chemical reaction. Okay? So through that, we need energy. Okay? To proceed the chemical reaction, just like us human being, we need also energy to do our task and activities. Okay? Like that. So it's very clear. Any questions so far? There's no clarification right now, so let's proceed. And now we go to the entropy. Entropy class is very common in physical chemistry. This entropy quantity or a property is not really discussed in chemistry, okay? But a sort of only touching a little bit for this. But this entropy is really the randomness and disorderedness of a system, okay? So for example, you are living in one room, okay? And then you sleep, you work, you sleep, you work, go back to work, go back to office, or go like that, everything. And then out of a sudden, your bed is very, topsy-turvy, okay? And then there's a lot of, stuffs, and you have to arrange that one, and very disorder, okay? Like that. So the entropy in your bed rises. Meaning to say, very random, disordered, and you cannot understand, then you have to arrange that properly so that it will become order. So originally, if that is the case, the entropy in your bed is very high, because entropy as a quantity in thermodynamics talks about the disorderedness and the randomness of your system, something like that, okay? So originally, so that's why you need to clean your room, your backyard, and everything, so that you have a good entropy in your system, in your home, in your body, something like whatever, okay? Something like that. So in your body, for example, you will need to take a bath because you smell so bad now, something like that. So you need to, entropy is very high, then you have to decrease that one. You have to take a bath, you go to shower. Okay, it's just like that, because entropy also refers to the molecules. If there's a lot of molecules bombarded and collided with each other, for example, in a certain container, then the entropy is very high, naturally, okay? So that's talking about entropy. And this entropy, the unit is kilojoules per kilogram Kelvin. And now, guys, very common in our denominator that there's a kilogram. Okay, troubleshoot that one. Oh my gosh, if you talk about specifics, chuba chuchu, there's a kilogram in the denominator, then bingo. Then if you try to solve really in terms of energy, the unit, then we can multiply that to a kilogram. Okay, usually also in a problem solving, you'll be given a mass, or it could be a volume directly. Okay, those scalar quantities, okay? You remember physics? There are two quantities, scalar quantities and vector quantities, okay? So most of the times, this can be multiplied by a mass, really technically, so that you can achieve the unit of kilojoules only for energies, something like that, okay? So in here, class, you need to have a thorough and adequate knowledge of physics and chemistry combined together. Especially if you love science and you can really understand what I'm talking to, then a little bit of, absorption of the information that I will be able to give to you as a chemical engineer, okay? And then I'm going to share ideas to you also if you love science, especially if you are a STEM graduate, STEM, science and technology, engineering and math, something like that. So this is very an appropriate topic for you guys. Okay, it doesn't have that you should be an engineer or whatever, chuba chuchu, to listen to this live streaming regarding thermodynamics or thermochemistry. So this is a steam table. The first steam table is temperature based on saturation. Now, Sir Sotero, what do you mean by saturation? Oh my God, when we speak about saturation, that is basing on 100 degrees Celsius. As we can remember, guys, if we Me, I'll make my coffee, then I have to boil the water. So the water will boil at 100 degrees Celsius. So it will be achieving its boiling point. And that is the saturation temperature with its relationship to saturation pressure. Okay, so the term saturation is really emphasized at 100 degrees Celsius. Okay? In reverse to that, that is the freezing point of water, that is 0 degrees Celsius and 32 degrees Fahrenheit. Okay? Now, I want you guys to memorize the basic formulas of temperatures also. Then I want you also to inject in your brain cells the formula of degrees Celsius, the formula of Fahrenheit, the formula of Rankine, okay, something like, and the formula of Kelvin. This will be used entirely class if you are really taking engineering course, especially in the subject of thermodynamics. Okay, and chemistry. We have a lot of chemistry engineering students, right? We have 4 semesters of chemistry. We have, I think we have 2 semesters of physics, something like that. Okay, that we will be able to use that importantly in our higher subjects, especially that deals with sciences. Okay, a lot will be deals with science, especially the electrical engineering also. Practical electricity is also under science, right? So talking about electrical energy. Okay, so mechanical energy also is under science. It talks about the movement. Okay, the movement could either be a stationary, static, and the rotary, or the motion of an equipment or machine. So it's also related, right? And also the civil engineering is also related to sciences, because you have to build bridges and you have to determine the center of gravity so that it will not be cracked somewhere along the way during the tension and the loading of those bridges. You have to compute force like that, weight, mass, centrifugal force like that, and everything that could be discussed also in the strength of materials and engineering mechanics. So all those kinds of engineering courses are also linked in sciences courses, but most of those sciences are really related to chemical engineering, because it's really science. We're really focusing on pure sciences as we go along the way in our higher major subjects. What I am telling to say, those kind of courses really involve sciences also as part of their courses. Then they have also to understand really the basic concepts and theories of sciences, because it will be incorporated somewhere along the way. Okay? Like that. Now, STEM, science, technology, engineering, and mathematics. Then if you want to become an engineer, then of course you must have graduate of STEM, I think so, in your senior high. Okay, something like that. If you really like, then you can take engineering course or anything that is related to science, right? Okay. It doesn't have to be mathematics just to become an engineer. All you have to do is to study hard. Okay, something like that. You have a very strong and a very, very strong passion in studying both science and mathematics. Okay, something like that. Okay, so this is gonna be hard. So sometimes the question in the problem will state also, especially if you are taking the examinations, whatever examinations relating to science, something like that. Blank is the properties involved in a steam, saturated steam temperature base, or enumeration. Or your answer will be 1, temperature, pressure, specific volume, specific energy, specific entropy. So you have now 1, 2, 3, 4, 5, 6 points na siya. If the question was stated in the problem, illustrate or give examples of the properties of a saturated steam at temperature base, or enumeration, or listing, or outline. So you can have now a score, because not all the time examination is multiple choice. Okay, sometimes you have to enumerate, you have to fill in the blanks, you have to identify, and the most very important type of question is, the most I love is the essay. I love essay question also. Okay, because it tests my comprehension ability. Okay, it needs critical thinking to answer those type of questions, the essay questions. Okay, so this is really to measure how how the mind of the students can really think to the logic of certain things, or the reliability of certain things, okay, something like that, then you can really understand. Sorry for that. Okay, like that. So, oh, it's very lengthy now. My introduction is very lengthy, right? Okay, so this is our problem. Okay. Oh, shout out to AG Lapos, Irene Cabug, okay, Ellen Rom Diaz, okay, Ellen Rom Diaz, what else? Joel Monir, Maricel Cabral, okay. We have Egyptian Ratanil, okay, shout out to you guys. So this one. Okay. A rigid tank contains 10 kg of water at 60 degrees Celsius. If 7 kg of water is liquid form and remaining in vapor form, determine the volume of the tank. So in this problem, it talks about two phases already. So you need to detect that it is really applying the steam table. Okay, so and then the problem also specified that it's only water, no other chemicals involved here in the problem. Okay, like that. So you need this steam table here. Okay, like that. So we have 60 degrees Celsius. Then you have to find the 60 degrees Celsius here, here, here. Temperature like this, 60 degrees Celsius. So I will now mark 60 degrees Celsius. Okay, so sorry, so I'll be able to do the continuation later, sorry. So I have to state 60 degrees Celsius right here. I'm using the steam table at temperature based because the problem is have temperature in the problem. Okay, so I have here 60 degrees Celsius. Okay, at saturation 60 degrees Celsius here. Okay, I have the specific volume. Okay, specific internal energy, specific enthalpy, and specific entropy. Okay, here, this one. So this I marked will be used in solving this problem. Okay, thank you so much for listening this live video. See you later. I will continue later. Bye bye.